Am I audible? Am I audible now? Okay, my voice is clear. Okay. So in last class, what did we discuss? In last class, what did we discuss about? My voice is audible or not? Okay. Need to need to disconnect হয়ে গেছে। क्यों? Okay, so now my voice is clear. Okay. So network is disturbing, that's why. So in last class, what did we study? We have studied about area velocity method, isn't it? So in area velocity method, there are different criteria where we can adopt this method. What are those? The stream should have a well-defined cross section. Well-defined cross section. Okay. So in last class, we have. Am I audible? Okay, in last class we have discussed about area velocity method, isn't it? So here the stream should have a well-defined cross section which does not change in various seasons. It should be easily accessible all through the year. The site should be in straight reach. That means the mat where you are going to apply it in that portion, it should be in straight, not in like curvy type. Okay, not in hilly area type. The gaussing site should be free from backwater effects. Backwater effects, you know, this is the forward effects and this is the backwater force, isn't it? This is your backwater force. And at the selected site, the section line is marked by permanent survey. So we have to do survey in that area. And then we have to apply. So in this figure, you can see the stream section where we have adopted, where area velocity method is applied. Only this portion is taken. Okay. Only this portion is taken here, stream velocity, stream section for area velocity method. Okay. So the following are the some of the guidelines. Am I audible or not? Now am I audible? Okay, so the guidelines where we have to select the segment width should not be greater than 1 by 15 to 1 by 10. These things we have discussed, isn't it? Calculation of ditchers. So there is one formula given, how we can calculate. Numerical is not discussed, isn't it? I think it is not discussed. So we will discuss the numerical later. And moving boat method. In this method, ditchers measurement of large alluvial rivers such as Ganga and standard current meter method is very time consuming even when the flow is low or moderate. When the river is in speed, it is almost impossible to use the standard current meter technique due to the difficulty of keeping the boat stationary on the first moving surface of the stream. So here, what will happen? In the flowing stream, we have to take the measurement. We have to take a marking. We have to take a marking. Okay. In this method, a special propeller type current meter is used. Okay. So what is current meter? Current meter is used to find out the velocity of a flowing stream. Suppose in a river, the velocity of a river can be measured with the help of current meter. Okay. Next, dilution techniques of stream flow measurement. The dilution method of flow measurement is also known as chemical method. Okay. So here consider a tracer which does not react with the fluid or boundary. Let C not be the small initial concentration of the tracer in the stream flow at section 1, a small quantity of volume of high concentration C2. Okay, sudden injection method. Let section 2 be sufficiently far away on the downstream of section A so that the turbulent mixing process while passing through the reach. The concentration, okay. So this is the formula to find out the ditchers in case of dilution techniques method. These are the tracer used. Last class we have discussed these things. Electromagnetic method. The electromagnetic method is based on Faraday's principle that an EMF, electromagnetic force, is induced in the conductor, water in the present case. So here the conductor will be water because we are measuring the velocity in a stream, isn't it? That's why the conductor will be water. When it cuts a normal magnetic field, large coils buried at the bottom of the central channel carry a current I to produce a controlled vertical magnetic field. Electrodes provides at the sides of the channel section measure the small voltage. Okay. So if Q is the ditchers, this is the formula of finding the ditchers. Okay, this is the electromagnetic method. Conductivity sensor, C is the conductivity sensor, V is the voltage problem, and is the voltage probe, and is the noise cancellation probe, and B is the bed conductivity probe. This method involves sophisticated and expensive instrument. Okay, and has been successfully tried in a number of installations. The fact that this kind of setup gives the total discharge when it has been calibrated and makes it net na pao eta ko bhulega and makes it specially suited for field situations where the cross-section properties can change with time due to weed growth, sedimentation, etc. Another specific application is in tidal channels where the flow undergoes rapid changes both in magnetic as well as in direction. Present day, commercially available electromagnetic flow meters can measure by discharge up to plus minus 3%. Okay, the maximum channel width can be accommodated by 100 meter. The minimum velocity detectable is 0.005 meter per second. Next is your ultrasound method. This is essentially an area velocity method with the average velocity being measured by using ultrasonic signals. This method was reported by Swagnell in 1955. Since then, it has been perfected and complete systems are available commercially. This is the setup of ultrasonic method. One transducer is there in a cross section of water. Suppose L is the length, theta is the angle. So V will be L by 2 cos theta. I mean L 1 by T1 minus 1 by T2. Thus, for given length and theta, by knowing T1 and T2, the velocity along the path AB, that is V, can be determined. It may be noted that V is the average velocity at the height h. Okay. Ultrasonic flow meters using the above principle have frequencies in order of 50 kilohertz. Sophisticated electronics are involved to transmit, detect, and evaluate the mean velocity of flow along with the path. In a given installation, a calibration performed by the current meter method is indeed needed to determine the system constant. So the specific advantage of using ultrasonic system is it is a rapid and gives high accuracy. It is suitable for automatic recording data. It can handle rapid changes in the magnitude and direction of flow as in the tidal rivers. The cost of installation is independent of the river size. So there are some indirect method of finding out the stream velocity. These are flow measuring structures and slope area method. Flow measuring structure using like notches, weirs, flumes, sluice gate for the flow measurement in hydrogravimetry as well. This conventional structure used in field condition also, but they are using limited in ranges of head, debris, and sediment. So the basic principle of governing the use of weir flume structures is that the tree structure produces a unique control structure section in the flow. At this structure, the discharge Q is a function of water elevation measured. So Q is a function of H. H is the water surface elevation measured from a specified datum. Okay. So using this structure, we can also find out the velocities. Okay. And last one is your slope area method. After that, what we have, let's see, check once. Stage discharge relationship. And then extrapolation of rating curve. All the things we will not discuss here, okay? Those which are important, only that portion will be that portion I'm discussing here. Okay, your next chapter will be after Slope area method we will discuss, go to the next chapter. Okay, that will be a runoff. Okay, so we will discuss in the next class. How many students? 26. Okay, thank you.